Hello friends, this is day 5 of doing Codeforces until I become a specialist. So, and today we are going to solve 13 problem of 800 ranking in CP sheet TLU eliminated CP sheet 31. Okay, so it's about United, United we stand. What is it? So let's try to understand the question first. So given an array A of length n, so it is an array and it has length n. So containing integers. It's an integer array. Okay. And there are two initially empty arrays like B and the C. These two are initially empty arrays that doesn't contain any values. You need to add each element of array A to exactly one of the array B or C in order to satisfy the following condition. So we can add each element of array A to one of the array B and another one to the array C. So we can know how we can actually put each element of array A into exact arrays B and C, which are initially empty. So both arrays B and C are non-empty. Okay, both are non-empty arrays. More formally, let LB be the length of array B and LC be the length of array C. Okay, they are not same arrays. B and C are not same arrays. They have their unique length. For any two indices I and J, uh, like Cj is not a divisor of Bi. Okay, for any two indices I and J, where I belongs to the index which is present inside the P array, and J belongs to the index which is present which is belongs to the C array. So for any index, their elements Cj must not a divisible divisor of Bi. So it's not a divisor of Bi means Bi is not a multiple of Cj. Okay. So output the array B and C that can be obtained. Okay. Otherwise, -1 if that doesn't exist. Okay. There may be a case present that where we have to return -1. Okay. So uh, this is just as before problems in input we have to read number of test cases here, but the test cases are equal 500. Okay. And here the first line of each test case actually contains a single integer which tells the size of the array A. And second line of each test case contains n integers, the elements of array A. So this is what we have. And what we need is the two arrays which have different lengths but not same. And for every element of Cj is not a divisor of Bi. Okay, that's what we know from up to here in this question. Okay, and now in output, so we just have to print the BRS and CRS for each test case of single integer. If the solution does not exist, -1 if the solution does not exist, right? So otherwise, in the first line, output to two integers LB and LC, the length of the array B and length of the array C. So this is the way we how to represent the array or elements of B and C if the condition is true. First, we have to write their lengths, and then we have to write in the second line. So we have to print the second array, which is nothing but LB here, LB integers, and in third line, so LC integers. That's it. So if there are multiple solutions out of 10, we can output the element of array in any order. So in CP problems, this line actually very important. Reading that line actually very important because sometimes depending upon the test cases we are finally came up with an intuition which we really thought, okay, this is my intuition. But when you run the code on that intuition, you may not able to get the outputs exactly which are presenting in the test cases outputs. Okay, this is caused because of you won't understand the test cases and the question properly. And moreover, but in this particular, if the question contains this particular line, that means even if the order of the output is not equal to the order of the output of the given test cases, it may be equal. Our code may be right, but not 100% sure. It may be right because of this line. So there are multiple solutions exist. Whoever who knows? Okay, it only contains these elements, this number of elements. We don't know, right? So that's it. So let's understand the test cases and the output. So for five number of test cases, first this is the size of array, three size of array, and the array elements are two, 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 and is that's output is minus one, three, two, one, three, five. Okay, so minus one is actually belongs to. Wait, wait, wait. First, we have to return the uh, output two integers, LB and LC, the length of the array B and C. So for these, minus one, it may be a length of array C and array B. Okay, for that, we have to 3 2. So why we get 3 2? Wow, I was opening this. Okay, uh, what is this? So I can, here the answer is 3 2 and 1 3 2. So for fourth test case, mm, okay, let me say 3 and 2 is the outcome of this array. Then what is minus 1? We don't know exactly. So, and this is the B array and this is the C array. So, 135 is the B array, 24 is the C array. Okay. Now, from the second test case, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2 is the first test case. And 1, 3, 5, 2, 5. So these are actually belongs to this third test case, and this is belongs to the fourth test case, and this is belong. Wait, wait, wait. This is not actually happens. So for the fifth test case, we have to represent the output must be in three lines. So this is the output of the fifth test case, and this is the output of the fourth test case, and okay, wait, wait. Okay, now this is the output of the fifth test case, and okay, okay, okay. And so, okay, this one answer for one test case, answer for second test case, answer for third test case, and this is exactly answer for fourth test case. So, but the size is minus one. So that means here this minus one actually belongs to the outcome of the first test case. Okay, how the minus one is actually came out? Whenever we thought, okay, whenever the element array element has a size same elements, we have to lose them, otherwise we can like fill them. So here 2 2 2 2, okay, let us just hold it that hold that thought. We have to like whenever we get 2 2 2 same elements, we have to uh, give minus one. So for the second test case, 1 2 3 4 5. So, but here the output is 3 2 and 1 3 5. Okay, so the first array size is 3 and second array size is 2. And you won't mention that uh, how can we put the elements into B and A. So first we thought take odd numbers into one set and even numbers into another set. Is that what he was doing? Okay, so let me check. Let me check. For the third test case, 1 3 5. So for the thought test case. So for the thought test case, 1, 2. So this is actually the answer. 1, 2. The answer is actually 1, 3, 5. So A array contains 1 only and B array contains 3 and 5. Even though 3 and 5 are odd numbers, as the length of the B is greater, so we have to arrange it like this. And you know the funny logic here. No, no, it's not funny, bro. Okay. Now 135. Yeah, okay. And 7 1 7 7 9 9 1 4. So this is what we have. So for the third test case, 2 5 1 1 2 4 7 7 9. So why is this? Here repeated elements are exist. So that's why we have to take those repeated elements into same set. And 7 is present in same set on 4 9 7. Okay, that's good. Uh, Here we have to understand a little bit. At first, I thought like okay, it's all about we have to grading the odd and even numbers, and we have to put them into a single set. But that's not what happening here exactly. See, observe test case number 4, 1 7 7 2 9 1 4. For that, the answer is 2 5 2 5 1 1 for 2 5. So 2 is the array size of the B, and so it contains elements 1 1. And 5 is the array size of 4. Okay, so basically he said that we have an array of size n and uh, array of size n elements, and we have to arrange these elements into two arrays. So in which uh, the arrays of one element shouldn't be a divisor of the other elements. So array of C element is not a divisor of B element. So here we have to understand another thing. We have to know what is a divisor. So divisor we already know. So it includes in division. By the way, so how can you say the divisor of a number is a particular number? For suppose if we have number 4 and divisor of that number 4 is actually uh, let's go on to the whiteboard. So if you have a number 4, the divisors of numbers are nothing but 1, divisors are nothing but 1, 2, and 4. So and if you can find the factors of 4, so factors of 4 are nothing but 1, 2, and 4. So like we can say the factors of a number is nothing but the divisors of that number, and the divisors of that number is actually the numbers from 1 to less than or equal to that number. So as we take n is equal to 4, so the divisors range has to be 1 to 4. Understand? So this is how divisors work, and we have to put the elements of array A into two sets. I mean, actually two arrays in which the array of one element shouldn't be a divisor of array of another element. And we also have one point here. If if we take the adjacent elements are not divisors for one, for two. Okay. Uh, so two, one is a divisor of everything, right? So we have to build an array. First one, we have to put an elements into this, and let me say this is B and this is C. Okay, and we don't even know the size of B and C. So, but the elements of this B are not divisible divisors of the elements of C. So this has to be unique. For that, um, we have to search for another point. By we can get it from the test cases. So if there are five, and here the arrangement is like 3 and 2. So why 3 and 2? So 4, 8, 4, 12 and 12. Okay. We forgot one thing. So there are n number of ways for this problem, and we just have to print any one of that way, right? So we have to use only a single condition which is common for all, and we can return that. Even if you apply that condition, we can get one result which is not may equal to these outputs of this particular fantastic case. Okay, so what we have, we just say we have to we have an array, and uh, as we before said, so we have to take the odd positions and take the even elements and put them into one element, put them into one vector, and even elements put them into one I mean, how can I say? So we can actually take out the all even numbers and odd numbers from it, and we have to put the odd numbers into one set and the even numbers into another set. So as odd numbers shouldn't be a divisors of the even numbers, so we can get right. But if we have one is a divisor of both odd number and even number, right? So so for that, whenever we get one, we have to put them into one set, and uh, and then we have to make the all other elements present in another set. Okay, let's try to use that intuition, and go check. Oops. So plus compiler. Okay, so we have to take the test cases and read the test cases on single test case. We have to take the n value which represents the array element, and vector of sizing, which it has to be the n, and we have to take the elements inside these vector. So Cin take out the element at this particular index. So now we have the elements inside the vector A. So now we have to pull another two vectors. We call it as B, and we don't know their size, and C. Again, we don't know their size, right? B and C. So what we have to do, we have to put the elements inside from one vector to the another vector. So what we have here, if we have one here in this particular test case, one one is present two times in this test case, but the output is like we just have to keep the ones in first set and keep all other elements in another set, right? So then only the condition is applied, right? So here, this is the array B. This is what we call as array B, and this is what we call as array C. And our test case is like Cj is not a divisor of Bi. So, so for one has a divisor two. No, it shouldn't, because one has the divisor less elements which are less than or equal to one. So that is there is only one element which is a divisor of one, that is one only. So here the condition is satisfied. So we have to somehow make all the ones together in one place. So which we can do it by sorting process, right? So for that we understand. So we have to sort this. We have to sort this. Okay. After sorting process, now let's start. We have all ones at one place, and we have to put that ones in a particular vector. I mean, in B vector only, not a particular vector. So for that, we don't know how many ones are exist, right? So while I can and take the index, I call it as I equal to 0. Okay. So if index I is less than n, and and we have to make sure that the that particular index element is actually equal to the area of first element. Then only those two elements are equal. So then we have to put that element into our vector v dot, so which is push by using pushback operator. So which is nothing but pushback function. So we just have to push that element, right, into this, and we have to increment the I value, and only it will point to the another one. So okay, now all ones are filled into B vector. Now we have to fill the other elements of the A vector. So A is always incremented. So that incremented value we have used here. So even if that is less than n, and here we shouldn't use this test case, no need of it. And we have to put those elements in C vector. Okay, right. So and we have to increment. Now we have two vectors. So but before printing them, we have to show their sizes. No, no, no. We just directly print the elements which are presenting in them. Uh, but if we have to print -1, we have to print -1 whenever it is not possible the elements which are at CJ is not is divisor is may divisors of elements of B. Then we have to print a -1. Otherwise, it also happens whenever the vector shouldn't contains any elements. In the worst case, like if we understand the first test case, we understand that if we see the first test case, we understand that so all elements are same. So all elements are same means nothing but uh, it satisfies the property like a of I is equal to a of 0. So these are actually present inside the B vector. That means a C vector doesn't contains any elements. That's why here -1. So -1 when came whenever uh, the arrays B and C that can be obtained output -1 if they do not exist. Okay, so if we can obtain the two arrays in such a way that the array elements of it C are not a divisors of B. Okay, the elements has to be exist. If the elements has to be hasn't exist, then even we have to print a -1. That means we have to check whether if B dot size equal to 0, that means it shouldn't contain any value, or C dot size is equal to 0, then we have to print -1. Otherwise we have to print okay, if we print that -1, we have to do we don't need to go to execute the other statements, right? So we have to continue, we have to use the continue keyword for that. And if this is not executed, this line is not executed, above if statement is not executed, then we should write the elements which are present inside the array. So I is equal to 0 and I less than b dot size, because we have to print the elements which are at b, and we can use simply cout operator and no endln. We just have to use b of that index value. After that, we have to give some space, because there are some spaces between the elements. So, and after this, we have to go to the second line, and there we have to print the elements which are belongs to the C vector, right? And there we have to print the next line character, so which is envelope. So let's try to run this. So here the basic thing we have to know is the proper uh, concept of divisor. Divisor, how a number should have divisors. A number have a divisor. The the number divisors are always less than or equal to that number. So if you know, okay, we just easily do this. D dot size. D was not declared in this code. B, right? Not D. Actually B. And BC. Okay, BC. Line number 26. Where is line number 26? Here. Okay. Let's write it. Rerun this again. 8, 12, 12, 4, 4. Okay. See here. The output is same. Output is different compared to this. Here, 484. But I got here. I just only put the elements 4, 4 and 8, 12, 12. Is 8 is a divisor of 4? See, I is not a divisor of BG. That's what we have to check. Is 8 is a divisor of 4? No. The divisors of a number is always less than or equal to that number. We have to remember this. So that's why we have to sort the initial array. So because when we sort the initial array, uh, we can uh, we can get this array as 4, 4, 8, 12, 12. So 4, 4. And 8. So if we take the number 8, so divisors of numbers are actually less than or equal to that number 8. So 4 is present. So 4 is a divisor of 8. Of course, it is a divisor of 8. So that's why by the help of sorting process, we have to take the all elements which are similar. We have to put them into a single element. I mean single in a but in a B array, so that B array contains the elements which are uh, same, and the another array which is C array contains the all remaining elements which are actually greater than the element, which makes sure that uh, these elements are not actually are the divisors of the B array element. So that's what we have to understand. So I think it's completely depending on the mathematics. Let's submit this code and check whether it is submitted or not, whether it is accepted or not. What is this? How to submit this? Rating changes from last round to temporary rolled back. Okay, sorry. How to log in into this Codeforces for submission the code. So b dot size and then and then say, mm, let's copy and paste and let's submit this. Three, two, one. Come on, come on. It's still running. Um, I think we are going to get anti-malware or TLU. Oh, it's wrong on test one. Why? We just implemented the property of the divisor. Okay, so we didn't get exactly the same as before. And what if uh, is okay? Shit. We have to print their sizes, right? We have to print the sizes before before we are printing the elements inside them. So for that we have to see out first. We have to print the vector B size, and with just little gap we have to print the vector C size, right? And then we have to move to the next line. Let's run this. One four. Cause here. Okay. Okay. So it contains 2 and 3, and it contains 2 and 5, and it contains 1 and 2. So everything is same. Whenever, so we just have to add this line to the code to make it submit according to my view. I think that's the actual view because we have to print the sizes after checking this. So let's submit it again. Into one united we stand. United we stand. I hardly find out the relation between the problem heading and the concept which is lies in the problem. I feel like it's not important at all. I think this is also not accepted. Okay, God must be crazy. It's accepted. So we solved this question, and let's go to the second one. Buttons. What is it? Buttons, buttons, buttons. What is my rating? 815. Fallen from 975. Ah, don't worry. I have to keep it up. So buttons. So button here. Anna, Anna. What is it? Anna. Oh, whatever it is. Anna and Kate ended up in secret laboratory. There are A plus B plus C buttons in the laboratory. It turns out that A buttons can only be pressed by Anna. B buttons can only be pressed by Kate, and C buttons can be pressed by either of them. Okay, I think you understand it. And Anna and Kate decided to play a game. Okay, they want to play a game, and what is it? Taking turns pressing these buttons. Anna makes the first turn. So she makes the first turn. Anna makes the first turn. Each button can be pressed at most once. So button can be pressed only at most once. So at some point, one of the girls will not be able to make her turn. Okay, definitely because there is only one chance. the button has to be pressed only one time. So one guy must not be able to press the button. Then the guy who cannot press the button loses the game. Determine who will wins if they play optimally. Optimally, so like if Anna has a chance to win, she don't lose that option. And if Kate chances to win, she don't lose that option. Apart from this, if Anna has what is it? Um, predicted that the move of the Kate, she actually blocked that move. And the same process is applied for Kate also. So which we call it as optimal. Okay, so they are playing this game optimally. Okay. The first line contains okay, and we have to read ABC. So A is the number of buttons that can be pressed by Anna. So Anna can press A buttons. So which is actually number of A buttons, and B are B number of buttons. Okay, C is actually not a button here. These are actually number of buttons. So that means Anna has to be pressed the key A into A times. That's what he want to say. See, and it's always less than or equal to 10 to the power of 9. So, is that means integer data type is enough to store these ABC values, right? And we have to print first if Anna wins, and if Kate wins, we have to print the second. So, yes, this is kind of a game question. For five test cases, if all are same, first person, that means Anna wins. And if two are same, Anna wins. If all are different, second person Kate wins. And okay, according to our guess, okay. And yes, see, so our guess is wrong because even though if two are same, here the first person is not actually wins. Yeah. So that's not the way. Yeah, we have to understand. For the simplicity of the problem explanation, we will eliminate the buttons by the number. Okay, 1, 2, A plus B plus C. The first A button can only be pressed by Anna, and next A button can only be pressed by Kati, and the next C button, Kati, or whatever the name is, it's just a name, right? So, and next C button is actually pressed by either of them, right? Um, so these are C button is actually decides who will going to win the right. Uh, so it's completely depending on C. Why I'm saying this because uh, Anna can only press the buttons which are in A, and this second person Kate can only press the buttons which are belongs to B. But both of them can press the button which are labeled as a C. So if you first uh, like make the C buttons equal to 0, then we have only two buttons which are only pressed by uh, their uh, their masters like here Anna and Kate. Like so, whoever have the less, they are ultimately going to lose the game. After C has to 0, so it is equal. But we can also do like so first if Anna, so we have to take make Anna buttons minus minus because we have to reduce their number of operations like and after that if it is Kate and still we have only one number so we have to write a loop for only one number and the for which it has to perform the operations uh, like which takes us to increase the code. So but if we think optimally like after reading the test cases and is mainly this line. I just understand. So this C button actually decides who is going to win the game. Okay. So now how it actually decides the winning process, winning winning person. Let's understand. if C is odd or even. So we have only two ways. Whenever C is odd, mostly the first person is winner, and whenever C is even, and here the second person is actually the winner. But here, even if the C is odd, here see this 1, 2, 3. C is odd, but as the A is less, the A is not actually greater than or equal to B, because Anna, in order to win the Anna, she has to be a greater number of times A button, then greater number of times B button, right? So yeah, always has to be greater than or equal to B after C buttons are finished in order to win, get a winning process for Anna, right? So I think so. Let's take this question on the board. Okay. So we have buttons like this is A button and this is B button and this is C button. So and Anna can only click the buttons which are under the A, and so Katha and this either clicked by Katha and so the question clearly says that the game actually started by Anna. Okay, so she actually pressed the button, and the second time C button is pressed by Kathy. So after first time it will become 2, and after the B person click the game, it will become 1, and after A person click the button, so now it will be 0. So now whenever C is equal to 0, uh, B find that it is equal to 0. It actually click this uh, it personal button, which won't be clicked by Anna. So now it is equal to 1. And Anna, so it also gets finds that C value is actually 0. So it has to be used its personal button. So which is after using it will become 0. And now here now the controller goes to second person Kathy. So it successfully click the button because it has a 1. So now it will become 0, and for control goes to Anna, so it finds 0 and you don't have anything to click. So here who loses? Anna loses and Kate wins. So Kate person wins. What if we have here 2 and 3? Okay, so after the completion of the buttons which are under this label C. Now the controller has to be uh, second person Kate, because so he clicked that first time, and Kate clicked that second time, and Anna clicked that third time. Now it will become 0 because it's equal to 0. And so whenever it's 0, it has to use its personal, B has to use its personal value. So now it will become 1. So after that, A has to click that, and after that, B has to click that. Now it will 0, right? So 0, and after that, he has to click that, it will be also 0. Now after that, controller goes to B. So B, it finds that it is 0. So as it is 0, so who will wins the game? Anna will wins the game. The first person who will get that 0 is actually loses the game, right? So now who wins? Anna wins. So our from the test cases, we say that A, whenever A is greater than or equal to B, and C is what? Odd. C has to be odd. Then only the controller goes to the like a second person, Kate person, because uh, the game started by Anna. Anna, right? So if it is even, C is even, the controller is again uh, by Anna. The controller again have by the Anna, right? So I think you understand this. I mean, this understand this intuition. So for the last test case, which is 288, so here it becomes C already becomes even. So C becomes even means A has the control. So A has the control. So whenever it happens, uh, so it actually more than strictly more than the second person because uh, controller is actually under the Anna now, not the Catherine, not the second person. If the second person have the controller, he has to the uh, one who click the its personal button first. But if it is under the Anna, like so let me say here there are only four. Okay, and Anna clicks it first, so it will become three. And Kathy clicks it, it will become 2. And Anna clicks it, it will become 1. And Kathy clicks it, it will become 0. Now, controller have by Anna, right? So Anna have the controller, so she has to click the button, its personal button, first time compared to Kathy. So now it clicks that, so it will become 1. And now Kathy, it will become 7. So it will become 0 here. So what if here it is strictly greater than the other? So let me say here we have oh, 3 and 2. Okay. Now Anna has the controller, right? So Anna has the controller. So she has to click. Now it will become 2. And now Kathy. Now it will become 1. Now Anna, it will become 1. Now Kathy, it will become 0. Now so we got already 0. So she is the loser. So Anna is the winner. When I was strictly greater than. Okay. So this is another case like whenever C is even. Whenever C is even, so the A value has to be greater than B to say Anna is the winner. Okay. So we are actually find the winning steps of Anna. So we have to take read three integers. One is A, B, and C. A, and we have to read B, and we have to read C also. Okay, after reading them, so what I am saying, we have to check whether C is divisible by C is an odd or even. So for that we have to divide that C value into two. So if we get 0, it is odd. If we get 1, so it is even. Whenever this C value is actually even, we have to check if A is actually greater than or equal to B. So then who wins the game? Anna wins the game. So that means we have to print first. Okay. Otherwise, we have to print second. Second, right? So if it is not, so that means C is actually even. Whenever it is even, it has to be more than B. It has to be more than B. Then only the first person actually going to be win the game. Going to win the game. Otherwise, he loses the game. I mean, she loses the game. So first and second. First, second. So same, right? So let's submit it. It's running. Accepted. Good. So these buttons is actually depending upon the game theory. In game theory, we have to understand each and every outcome. What if we put in this way into in that way into this way, like that. So I heard that most of the game theories are actually solved by the recursion. Yes, recursion are DP processes, dynamic processing. Sorry, dynamic problem solving method. Okay, and so let's go to the second question. I think you completely understand. I hope you completely understand this question. B. Okay, here we have just A, B, and C values, right? So we have to read that. Right? Um, compare. So who will win the game and when they will win the game, right? Okay. Now, okay. I think this is the last problem for today. An array coloring. So you are given an array consisting of n integers. Your task is to determine whether it is possible to color all its elements in two colors in such a way that the sum of the elements of both colors have the same parity, and each color has at least one element colored, right? So we have to know the meaning of parity. So parity. So let me open parity. Means state of condition of being equal, especially as regards status RP parity. Mathematics, in fact of being even on odd, if the fact of being even or odd. Okay, so even or odd here it we say it as a parity here. Yes, and we have to construct the mathematics only here. So we have to check whether the sum of all elements of both colors have the same parity or not. So that means they are odd or even. We just have to check it, right? Okay, I get it. So we just have to add the all. Okay, right. We already have the here best examples. So if the array contains 1, 2, 3, 1, 2, 4, 3, 2, 3, 5, 4, so we can color it as like 1, 2, 3 have one color and remaining all having another colors. So if we add the first color elements, so 3 plus 2 plus 1, which is actually equal to 6, and remaining all color values the elements actually 18. So here is 6 and 18 are belong to the same parity. That means are belong to the even or odd, but not the same. Okay. Okay. 6 is even and 18 is also even. So we can say yes. We have to return as they are belong to the same parity. If it is not, like here 6 and here it is 9, so we just have to return no, they are not belong to the same parity. Okay, it's a nice one. For t number of test cases, we are containing actually the n number n, which represents the length of an array, and number of elements, n elements inside an array. Okay, so we have to return as if it is possible to color the array in two colors in such a way that the sum of the elements of both colors have the same parity. Okay, okay. Otherwise, we have to return s. Otherwise, we have to return no. Sorry. Um, it's quite simple, but we have to check. Also, let me see. I have 4 and 7. I only up to the size 2. I have only 4 and 7. So they both have different colors. Unfortunately, 4 is odd and 7 is 4 is even and 7 is odd, so they are not equal. So that's why it is no. And 398. So for the test case 398, what actually happens here is if 3 is colored, 3 and 8 colors are colored in same and 9 is colored in different. So the result is 8 plus 3, which is equal to 11. 11 and 9. 11 and 9 are odd or even? Odd. So they are belongs to the same party. We have to write S, right? So no test case. So this is also no test case. How it going to be no test case? So if we print 5, 4 to the same color, so which is actually 9 and 3, 4, 5, 6. So 9 and 6. 9 and 6, 1 odd or one even. So if we take odd 5 and 4 plus 3 7, 7 plus 3 10, which is even for 6 even. So 4 plus 3 7 plus 2 9 odd. So unfortunately we will not make them belong to the same either even or odd. So that's why he had to return no. And 50 and 48 as both are even, so we have to return as so see the first sample is described that in the second sample there are only two coloring elements, 4 and 7 and 4. So this coloring stuff is actually imaginary stuff. We have to like understand that already. So if two colors like either 4 and 7 and 7 and 4, but in both cases the parity of the sum is actually different. You don't need to actually paint for all elements. We have to check is it necessary to check whether these elements are having painted or not, and up to the length of n. It's like a huge process, and which is not actually mandatory in these uh, 811 TLE CPU sheet definitely. So how can we solve this? How can we solve this? How can we able to solve this? We have to read the size. Okay, after reading the size, you have to check it parity. Uh, odd, even, odd, even, odd. Odd plus odd is actually what? 3 plus 3, 6. Odd plus odd is actually even. And odd plus even, so 3 plus 2, odd. So odd plus odd actually, I don't understand why I'm thinking like this. Um, so odd plus odd actually even, and odd plus even actually odd, and for even plus odd actually odd, and even plus even actually even, right? So it actually like 2 plus 2 4, and 2 plus 3 2 plus 1 3, which is odd. Okay, and here so odd is added to odd, you can get even, and even is added to odd, you can get odd. As we have to find whether it belongs to the odd parity or even parity. We don't know which is actually colored. If we know the which one is actually colored, then it will be simple, right? We should have to assume that okay, this one is colored um, or what? Okay, how So we have to check whether the parity of the summation process is same or not. If the summation is even summation, so it has to be divided into exactly half, right? So like we have summation this one, and as we have to uh, break this summation into exactly two, so we can able. So these two are actually same parts. So like this is even, this is even. The whole is also, the whole thing is also an even. Okay, this consider this whole thing is also an even, right? So if it is the whole sum is even, we can easily break that into two events, which having two alternate colors, and which having same parity. I think you understand it. So if it the whole sum is even, right? If the whole if the whole sum, so this is the whole sum. So if the whole sum is even, that means we can actually divide that sum into two equal parts, and we have to print one part as one color with one color and another part with another color. Okay. So and when we compare these two parities, so uh, is even is divided into two parts, that must be that parts are also even parts. So these even part and this is also an even part. So if parity is even, if parity is even, so same. So whenever we get summation as even summation, we can print as directly, because we can able to break that into two. And if we can get the summation as odd summation, we cannot make that into two equal parts, right? So sometimes we can get a five, sometimes seven. We shouldn't able to make that into two equal parts, right? Then, but we already know, if we can add odd value to this odd value, what happens? It will become even here, like 3 plus 3. So here 3 plus 3 is actually equal to 6. 6 is an even, right? Understand? So for these are the sum. So now I can get the summation as a odd summation. And if that odd summation is actually become gives 0, like if odd summation is actually 0, if it is an even, odd summation is actually even, then we can exactly do this process, because odd summation we can make that odd summation to even. Otherwise, we shouldn't make. We have to return a no here, not as deadly no here, and for this we have to return s value here, right? So let's go and code it out. So all we just do is uh, we are reading the values a n, which represents the number of entries, right? So after that, we need a vector which stores the integer data type. We call it as a, right? So this is vector a, and it has to store the values first, right? We have to store these values first, and I equal to 0, I less than n, I plus plus. In yesterday's core process problem, we understand that instead of writing two for loops in order to know the summation of the entire elements inside a vector, we can simply take the value outside of the first for loop, like summation is equal to 0, and after adding the element into that vector, uh, we have to add that element uh, to the summation value. So then the summation is also incremented. Now we have the summation which is stored in S. Okay. The, right. So now, if summation is actually even, now summation divided by 2. So if the summation is actually even, we have to print s, else we have to print no. Summation is always equal. Uh, right? Uh, Summation is even, okay. But if summation is not odd, then what should we do? We have to check whether the summation has this number of odd values. Summation is even. Let's understand the problem here. Your task is to determine whether it is possible to color all its elements in two colors in such a way that of both some of the elements of both parties have the same value. Same value. Okay, if that sum is actually odd, okay, then what should we do? Because see here, uh, 7 plus 1, the sum is 8, and 8 plus 10, 8 plus 10, 20, and here it is 8, 8, and here 5 plus 4, 9, 10, 20, 9, 15. So 15 is actually summation of odd. So it's the summation of odd. And here 50 and so 40, 98. So this is an even summation. And 9, so 9 plus 7, 16. An even summation. Without even summation. 8, okay. So if the summation is odd, 4 is 7 plus 11. So for second question, that's why it is odd. And for here, 1 plus 2, 3, 3 plus 4, 7, 7 plus 3, 10, 10 plus 2 plus 3, 5. That means 15, 20, 24. Okay, it's maybe agreeable. Let's copy and paste all the test cases. Okay. Compilation error, summation 0, summation add, and what is a compilation? A was not declared in the scope. What is he saying? Vector of which is type integer type, of size n. I'm actually declaring the A. Like, if you understand the basic approach. What is this? Come on, you can solve this. V was not declared in this scope. Okay, line number 13. Go to line number 13. He's saying V was not declared in this scope, but here I'm actually declaring a vector in that scope. Actually putting the element. Uh, okay. So I'm actually giving a size. So you can. What is what is the thing that I am missing here? Why it is entered here? I'm reading for any number of test cases. I'm reading the test case earlier and I'm initializing. Here it is considered as the same line. Okay. Surface value. S no SS no SS. S no SS no SS. That's our basic approach whenever we get an I don't even know whether it is accepted or not. So, but let's see. Even I'm curious. I covered it. We should get the same parity. Uh, I only have one question runs in my mind. For odd, we can also get the even when we add odd value to it, right? Oh, running on test case one. Okay, it may be right. For running on test case two, we have to think about it. Come on, you're taking too much time. Okay, if you're accepted or rejected. It's accepted. Huh, quite surprising. Really? See here. Wow, that's great. That's really great. Even that question that runs in my mind is uh, for odd number of sum, we can get odd number of parity. If you add odd number of value, we can get even. And for odd number of, if you can add even, okay, okay. There is no future here. We can okay for if you get the summation odd, you can able to add this one. You can able to add x number. Like if there is, we can add. So he clearly said that you just have to find the summation of values and if the summation of values of the two colors, there are two colors, right? So, but we don't know which one is which color. You just have to find the summation of those values and uh, both colors, if they have the same parity, summation of the colors have the same parity, they have to be say as it is true exist. So, okay, uh, this is today's code forces work. So we will meet tomorrow. Thank you for watching this video.